As I told you several times, Unit 3, the test 3 that you'll take in December, that will be cumulative, so everything that we have covered in the entire semester gets tested on that test. So most of the test is review with just a few new things thrown in. We're going to work problem 1 so you can see basically one new idea. The new idea is how to use the chain rule by itself. You've been using the chain rule with the other rules. Like the one I gave you is really a power chain rule combination and the natural log chain rule combination. But this problem is going to require the chain rule kind of by itself. It's not hard, but let's get going here. So as I read the problem, they give a bunch of information. Then finally I see the question. The question is right here. Find that second derivative. Can't find the second derivative until you've already found the first derivative. So you should write in your notebook this. d over dx of f of x cubed. And once again, please don't copy what I do. It is useless. Okay? You've got to learn for yourself what it means to understand something. And once you do, then you just kind of wave and you have me talk again. You just have me say it twice. You have me say it a different way until you're like, oh, I see it. I understand the idea. So we have to find the first derivative. Any questions so far? Okay. Here's where the, oh, please have it.
So when it says like the d squared and dx squared, is that just saying second derivative?
Correct. Perfect. 2 points. See, derivative of f of x cubed. Here's where we must use the chain rule by itself. But using the chain rule is almost exactly like doing this. So think of the blue and the green as almost identical. The only difference is the function here is just called f, and the function here is called sine. Otherwise, they are the same. This is the function of f, f of x cubed. This is sine of x cubed. Please.
Wait, so would you then just go like f prime of x cubed and then do 3x squared? Whatever. That makes sense.
Hold on 1 second. Danny followed the comparison perfectly. And the chain rule is really that simple. That's why using the chain rule by itself is not a hard new concept. Here we take the derivative of the sine, which is cosine, plug in the x cubed, followed by, we multiply by the derivative of the x cubed. Here we take the derivative of f, which is f prime, plug in the x cubed, then multiply by the derivative of the x cubed. It's a perfect comparison. It's really easy. If this makes sense to you, this is not hard. Other questions? Please.
Like on the blue paper, so the chain rule, can you write that? Like
So the chain rule on the blue paper says this. It says if you're trying to find d over dx of one function with another function inside, like that.
So gx is x.
Correct. So f, in the green case, the f is the sine, and the g of x is the x cubed. Over here, f is just f, but the g of x is the x cubed. This is equal to derivative of f with g plugged in multiplied by derivative of g. That's the rule. And that's what we did. We've got d dx of f with g plugged in. So do you see the comparison so far that you've got d dx of f, and the argument plugged into the f is g here and it's x cubed here. Okay, look at it, Allison. You okay that the ddx is the same?
Yeah.
Okay, that the f is the same.
Yeah.
This one has an extra parenthesis there. I can add that if it helps. Okay, what's inside of this f function here? This one.
G of x.
Right, what's inside of this f function?
X cubed is G of x.
In this example, not up here, but
Oh.
again, like if I'm trying to compare the blue to the rule,
Okay.
then yes, x cubed is g of x.
Okay.
Then the rule says you're supposed to, that this derivative is equivalent to f prime, so I wrote f prime, with g plugged in, so I plugged in g, multiplied by the derivative of g.
Okay.
You good?
Yeah.
Point.
On this or whatever, in the blue, you know how you did the derivative of x cubed, right? So where you go to where g of x is inside, you know what I mean, where it's f of g of x. If it wasn't just g of x, let's say it was like 4x, would you have to do like the derivative of 4x after?
You'd have to write down exactly what you're saying. I can't follow without writing it. Tell me exactly what to write.
So like so everything.
Just tell me exactly what to write.
Okay, f parenthesis g parenthesis like 4x.
Oh, there you go.
Yeah.
So that would be the chain rule you take. So if I'm doing this derivative, okay, everybody, don't just listen passively to other people's questions. Like he's hit a golden one. Like if the following will make sense to you, you're way ahead. So make sense of this. To find this derivative, I'm going to use the chain rule. So this is f of something. Okay? So the chain rule says it's the derivative of f with the something plugged in multiplied by the derivative of the something. So now I have to use the chain rule again. The derivative of g of something will be g prime of the something multiplied by the derivative of the something. It's the whole inception thing. Okay? That's it. Perfect. 2 points, please.
Okay, so I think I understand how to use the chain rule and just how it's taking the derivative of a derivative. And the green part makes sense. But just in the question, I'm getting lost how it goes from, you have the derivative of g of x, and g of x is the derivative of f of x, and so it equals f of x squared. But then what do you do when it comes to the cubed, and where did the cubed come from, and when you square the d over dx squared? That's all just a little
You're good.
confusing.
Pause on that for 1 second. Is it real good here? Please.
So, like, in the rule, it's f of g of x, right? But I guess in the problem, it's the derivative f of x cubed, right?
So the rule says the derivative of f of g of x. In this particular case, we're finding derivative of f of x cubed. Keep going.
Okay, yeah, and so I guess the rule is g is a function, and x cubed in the actual problem isn't a function.
Well, x cubed is a function as well. It's just a very specific function. Whereas here, g of x is just like generic.
Okay.
That's all. 2 points.
Okay, so that red one, at the end, isn't it? At the end, isn't it just d of x over d of x, like in the equation?
The equation I gave you on the handout, you can just, the d of x over dx is confusing people, so I would cross that out. That was kind of a mistake. I could explain that later, but just cross that out.
So you do just do like.
Yeah, this is correct.
Okay.
Anybody else?
So going back to the problem, you would have f prime of x to the 3, and then you would find the derivative of x to the third, which would be g prime, which would be 3x to the second, and then would you define the derivative of that?
Pause 1 second, I'll show you. I think I know your, if I don't answer your question, they'll speak back up again, Mikkel. Anybody else? You want to address your question?
One more that came up with the red, and
Yeah,
this
please.
question made me think. When you look at the formula on the blue paper, were you talking about the d of dx Or
Just
dx
the-
over dx there? Which
Yeah,
is
on the
what?
very end, just cross that off. I think that's
Okay.
causing confusion.
And then, but then what is the d of 4x over dx? Is
Right.
that
So
referring
cross
to that?
off, no, it's not. So
Okay.
that's what's messing with it. It kind of is, but I think it's causing trouble.
Okay.
So cross that off.
Okay.
The chain rule, what I did is I used the chain rule twice.
Okay.
So I said I've got f of this. So the chain rule says the derivative will be f prime of the same thing multiplied by the derivative of this thing.
Yes.
Okay, well the derivative of this thing is g prime of this thing multiplied by the derivative of that thing.
Okay.
It's the chain rule twice.
Okay. I think that makes sense.
Like the chain rule within the chain rule.
Okay.
Up here, Rachel,
Uh-huh.
here's why they confused you. All of this is not a question. It's just information that we will use at some point in the problem. We just haven't used it yet.
Okay.
So none of this applies to any of this yet. We're only working on this.
Okay.
No worries.
Wait, so you put the blue into the chain?
So right here, it says find the second derivative of this thing. That's what this means. You just have to memorize that. This means second derivative of this. There's no way to find the second derivative until I found the first derivative.
Oh.
So I'm working on the first derivative.
Oh.
Which one do you need? Just read the name. Read the name.
No.
No original. There you go. Question? Awesome. Okay. Can I erase the rule? Everybody? You good? Can I erase the red? Can I erase the green? Okay. Okay, so we have the first derivative. We now need to, let's finish though. So this is 3x squared f prime of x cubed. We're good there? Kelsey, your question again, I forgot it.
Watching you solve it will probably answer
Okay,
it
that's
someday.
okay. So now we just do the second derivative. So we need to take the second derivative of this. Sorry, we need to take the derivative of that. So that's d dx of that thing. Say it out loud, please. What rule do you think I need to use first? Louder. Product rule. So I take the second, f prime of x cubed, multiplied by the derivative of the first, plus the first, multiplied by the derivative of the second. Questions?
I have you take it.
You're too generous.
No.
Thank you.
Yep.
Okay, on step 2 to 3, where you like derived the x to the cube, did you just put it in front of that prime x cubed?
Like from here to here?
No,
No.
2 to
From
3.
here to here. Right. These two are multiplied.
Why did, okay. You
So
just
the
put it
order
in
doesn't
front.
matter.
Okay, and then why do you derive the whole thing instead of just the f prime? Like,
Oh, so
like
the
on
goal is to
3
find,
to 4.
the goal is to find the second derivative of this. The
Oh.
way you find a second derivative is
So
to
that's
find
what
the
the goal is,
first and then
okay.
do it again.
Okay, because I was like, I don't know why.
I understand. You're good. Elijah.
So you only use a chain rule when it says f of something in the equation?
Yeah, the purpose of the chain rule is when you have the derivative of a function with something inside.
And is the only way they represent functions f, or do they represent it with
Uh,
constant as well?
No, like f of x, g of x, h of x are common. Sine of x as well. It's just we happen to know that the derivative of sine is cosine.
Oh, so that's what these short terms are. Okay.
Does that make sense? 2 points. Natural log, same thing. We good? Awesome.
Wait, can you explain how you the part again?
So the product rule,
Oh, okay.
you good now?
Yeah.
So I take the second times derivative of the first, first times derivative of the second.
Okay. Yeah.
No worries, 2 points.
Thank you.
Here we go, next line. So we got f prime of x cubed. This becomes 6x plus 3x squared. Now I must use the chain rule again.
Oh my heavens.
Okay, but the chain rule is the easy one. Okay. So the chain rule is okay. The chain rule is the easy one. Okay? You've got the derivative of a function of something. It's very easy. Function of something. Just take the derivative of the function. So say it out loud, please. What's the derivative of f prime? F double prime. Plug in the argument. Now you take the derivative of the argument. The chain rule is the easiest one because you've been using it all the time. So you're used to the pattern already. Just like Danny saw, it's the same pattern. So, anybody else?
Why did you add it to the previous?
Look at it.
Oh, right. Wouldn't you just make it equal to the next step or something?
Let me say it back to you. This line must equal this one. I have to maintain equality. So this part I just rewrote. D of 3x squared is equivalent to 6x. So those are the same. Gotta have a plus. There's the 3x squared. Per the chain rule, you take.
I see.
Okay. Please.
So if you're looking at it in comparison to the rule, and so you know that if you have the derivative of f of g of x, so that equals f prime of g of x g prime. So the f prime in the equation would be like the f double prime in this problem, right? And then the x cubed would be like the g of x, and then you have the derivative of x cubed would be the g prime of x. Okay, let's just check.
Perfect. Please.
So why, when you take the derivative, why isn't the first f prime of x cubed just f double prime?
Because there's nothing here saying to take the derivative of f prime.
Oh, okay.
2 points. 2 for Rachel. Okay, next line. So this becomes 6x f prime of x cubed plus 3x squared f double prime of x cubed. This becomes 3x squared. Next line would look like this. These three things are multiplied, so I'm free to do a little multiplication if I choose. Question. You're doing a good job on questioning. The whole point here is not to copy. Copying won't help.
So just on the question when it says you need to find d, it says it has that square because it's trying to find the second derivative. Then when you do it, when you do notations, we don't need to have that 2 there because you're doing it twice.
Correct.
So if the question said then d if it didn't have the squared, then could you just be done after the first one?
Huh?
Okay.
Yeah, you'd stop here. Perfect. 2 points. Okay. Can I erase all of this? Do you have this in your book? Welcome to real life. Okay.
I don't like doing that.
Welcome to a real job. So, hold on. Erase McKell's quote. Okay, we're finished, except that doesn't match the answer. It does appear to be D. I mean, the others don't look nearly as close. Let me show you how they get to D.
Can you just move it?
Okay, this is where the red material here comes into play. I look up and notice it says the derivative of f is g. The derivative of f is equivalent to g. So f prime is the same thing as g. This is a great example of an AP question that adheres to my advice. If you try to just copy what I do in class, you're hopeless on the AP test. Hopeless. Okay, you have to understand what's going on. You have to just speak up when it doesn't make sense. Is everybody good to hear?
So all it's doing is changing f prime to g, just that simple.
Yeah, it's that simple. Because f prime and g are the same thing. And then here, the derivative of g, let's write that out. It's a little hard to see. Look. The derivative of g is g prime. So g prime is the same thing as f of x squared. Watch me, come on. But I already know that g is the same thing as f prime. So that means that f double prime is g prime. They're testing to see, are you someone who knows what equal means? Are you someone who just thinks equal is a fancy arrow? Okay? Equal means these are the same. You need me to talk more about this.
Let me just go over that one more time.
Absolutely. I find it confusing myself. It's just a series of this equals this, therefore this equals this, therefore this equals this. For example, are you okay with this one here, that g is the same thing as f prime? That's this one. F prime is the same as g.
Yeah.
You good with that?
Yeah.
Do this, Elijah. Take this one. If we differentiate both sides, we don't violate equality. So I can tell you that g prime is the same thing as f double prime. Okay with that?
Yeah.
So in this equation where it says f double prime, I'm going to replace that with g prime, but g prime is f of x squared. Anybody else? Awesome. Can I erase all of this? Now is it in your book? Okay. So get rid of all this. What someone just said is 100% correct. When you understand it, your brain like lights up. Like it loves the feeling. Your brain hates memorizing stuff that doesn't make any sense. It like refuses to do it. It just vomits it back out. Serious. Like you can't remember things that don't connect because your brain won't retain it. It just throws it out. But when things connect, your brain's like, ah, that feels so good. Please.
So as a derivative of x, f prime of x times the derivative of x, but that would become 1. But
Perfect.
For that instance, when you put it into g, when you said you put the f prime x to the 3 to g of x to the 3rd, wouldn't you also need x to the mean the derivative of x to the 3rd?
You got to tell me what you're saying. I got to write it down.
It's really.
I know. Just tell me to write it.
So the f of the derivative of f of x.
So you want d over dx of
f of x
want to do this?
The one we, yeah, for the example. And then that would equal the f prime x to the third, and then the derivative of x to the third, right? So wouldn't we need that chunk in order to transform it into g of x on the right?
You want to change this to this?
So you said like the equation up there, in the, that's underlined in red on the left, that says f of it. Sorry, it's super confusing. But you said you needed the derivative of f of x.
Yeah, this says that this says basically that f, the derivative of f is just g.
Yeah.
The derivative of f alone is just g.
And that thing on the right would
But
be
this isn't the derivative of f alone. This is the derivative of f of x cubed. That's different.
Yeah, but we're using the derivative of x cubed, aren't we?
This is not the derivative of f of x cubed. That they're different.
Yeah.
This is f. I know it. I can see why it's confusing.
So
We're
then,
gonna have to-
how are we able, if it's not the derivative of x
It's okay.
cubed, then how are we able to change that into g of x when we need that?
Gotcha. Let me see if this will help, and then the deeper questions might actually just need alone. Just hey, Weston, your questions are very good. I'm really serious. Like, I can see why it's puzzling you. See if this helps. Okay, this says. You're just gonna have to wait.
Yeah.
Yeah. Sorry.
I'll ask you.
Plus, it's just a longer conversation, Weston. Okay, we figured out here that f double prime is equivalent to f of x squared. Okay, I gave you a hint the other day. I said whenever you replace a variable, make sure you replace the variable with parentheses. So we've got f double prime of x cubed. I don't know if this helps or not. Look, this says the derivative of g, which is really f double prime. So f double prime of any x is equivalent to f of whatever squared. So we've got f double prime of x cubed. That means this becomes f of the x cubed squared. To square something means to multiply it by itself. So you have that, which becomes this. Please.
Okay, so when you put in like the variables in parentheses, are you putting x cubed like to the squared? It's not x squared to the cubed.
No, it's x cubed to the squared.
So how do you remember that?
Because, yeah, that's tricky. So the rules, what they told us was f double prime of something is equivalent to f of that same something squared. X is not specific, x is just whatever. So here I've got f double prime of this. That's equivalent to f of this squared.
Okay, so that x is that x.
Yeah, x is just a placeholder. X is just holding a place. Okay, eyes on me, everybody, look. Okay, I picked the hardest one I could find in all AP tests to do together. Okay, this one is the worst I've ever seen. That deals with this idea of the chain rule. There's a couple more in the packet of the, a couple more in the 1 through 25 that you're going to try and do on your own. Listen, you do your best to understand it, apply, see if you can get the right answer. If you don't stress. Just come back and ask me about it. Okay? Question.
Hey, so you don't like pull out like a 3x or something out of it?
Like an x cubed, you mean? Or like factor it?
Yeah.
You could factor it, they just didn't, so I did. That's all. Good question, 2 points. Okay, next one. Look at number 3, please. Look at number 3. Okay, you're going to try and see if you can get number 3 on your own, but I wanted to show one thing that people often don't understand. they say that h of x is equal to f squared of x minus g squared of x. A lot of people don't realize that means this. So this is h. And then you're supposed to find h prime. So I'll let you try and do that on your own, but I wanted to make sure you understood the first step. Question? Please.
That's like the same thing with the cosine and sines too. If it's the squares on the cosine, you can like pull it out like constant.
Yep. It would apply to this one too, Brennan. Like if you have the natural log of, I don't know, x plus 1, they put a square right there. That really means the
2 ln x plus 1.
Not 2.
Or yeah, but when you're deriving it, you can pull that
Yes,
out.
when you start taking the derivative.
That's what it means.
Very good. Very good. Awesome. So you'll finish that on your own. We shall see. That's funny. You write down number 7, please. No, I just got you started on for you'll finish that up. That's all. Just the square thing, Danny, tends to throw people. So I thought, good to point out that. And I think you can do it from there. So. Said with great confidence, Avery. The thing I wanted to point out here is that I find dividing to cause problems, so I try to avoid dividing. So rather than think of it as x over 2, I think of it as 1/2 x. Okay, to me, it's easier to think of that as the cosine of 1/2 x. So I did the first step for you. They want you to find the second derivative. I did the first derivative. The 2 is a constant. The derivative of cosine is negative sine. I don't want to look like I'm subtracting, so I use a parenthesis. So it's really just the chain rule again. Derivative of cosine is negative sine, multiplied, no, not multiplied, of the 1/2 x, multiplied by the derivative of 1/2 x, which is simply 1/2.
So did you start out using the product rule?
So no, the first rule I used was the constant rule.
Oh, no, I meant the ones to be after.
After this?
Yeah.
No, from here to here, there's no calculus. I just said, hey, I've got 3 things being multiplied here. 1, actually 2, 3, 4. And I just chose to multiply the 2 and the 1/2 first. That produced 1. Multiplied by the negative 1 gives me negative 1.
So after that.
Now you'd have to take another derivative because they're asking for the second derivative. So again, I've not finished the problem. I'm just helping you get started.
That's the derivative of x over
This is a 1. Because there's really no such thing, Avery, as negative sine. It's negative 1 multiplied by sine.
You could still do it without taking like the fraction.
Yeah,
Yeah, it's
just my preference. Next one. Please write down 13. Okay, 13 gives you a piecewise function, and then they ask all these different questions. Most of the questions are all about being continuous versus differentiable. Okay, so you got to harken back to Unit 1, and remember that the first requirement for differentiability is continuity. So I never work a problem by checking differentiability first. Makes no sense. If the function's not continuous, it's not differentiable. So one of the 5 answers here is impossible. There is no way for one of those 5 answers to ever be true. Raise your hand if you know which one. There is no way for one of those 5 answers to ever be true. Which of those 5 cannot possibly be true in any situation ever? Tristan votes for B. 2 points for Tristan, but that's the one that is commonly true, actually. it's okay for a function to be continuous and then not differentiable. So what's the one that can't ever be true? Let's go, Cass.
C.
C. You can't be differentiable if you're not continuous, because you must first be continuous. How many knew it? 2 points. Questions? Okay. We're supposed to figure out if the function is continuous at x equal 3. Well, you need to remember the flashcard that you built from Unit 1. It's this in orange. Ignore the blue for a minute. A function is continuous at x equal 3 if the limit from the left is equal to the value of the function in the middle is equal to the limit from the right. Questions? Cool. So I need to check these. So just say it out loud, please. As I'm looking at this, and I look at the formula up there, do I look at the top, bottom, or both? Weak. Say it again. Ah, much better. So let's see. When x is close to 3, the top formula will be definitely close to 9. Does anyone want to talk more about this? Is reviewing from Unit 1. More about that. To find f of 3, do I use top or bottom? Bottom. Good. Question? So f of 3 is exactly 9. That's why this is false. F of 3 is defined. This one uses the bottom formula. I get 9 again, so the function is definitely continuous at x equal 3. Please.
So I just have a question. So what does it mean when a function is defined? There was on the last packet there was one where the answers about like being defined. I'm not sure exactly what that meant.
So remember how we talk about that a function is just a list? Got it? As you read down the list, if you ever get to an x and there isn't a y, then the function is not defined at that x.
Okay.
Did that answer your question?
Yes,
Perfect.
Thank you.
Would that be like a whole or just continuity?
Yes.
Okay.
Yeah. Now, careful though, because if there's a jump, the function can be defined everywhere.
Because there would be something
There, just if there's a jump.
But if there's something like a hole or a gap?
So a removable discontinuity definitely is a place where the function is not defined. A vertical asymptote is definitely a place where the function is not defined.
Okay.
But a jump, the function can be defined. It doesn't have to be, but it can be.
Okay.
Point?
Is that because like where one would have a hole, the other would have?
Right. So there'd be a point here, Brennan, and then there's not a point here, but that's okay because it's still defined.
So it's corners, asymptotes, and.
Let me say it back to you. You're getting it mixed up.
Like
So-
what's not differentiable?
Differentiable is this. The function first must be continuous. Second, can't have a corner. Third, can't have a vertical tangent. So differentiable is first must be continuous. Second, no corner. Third, no vertical tangent. That's a flashcard. Elijah.
And does differentiable mean you can take the derivative?
You can find the derivative. Yep. 2 points. Anyone else? Okay. To figure out whether the function is, so you should remember this from Unit 1. Okay. So we use this to answer questions where there was some sort of picture. Well, now they're asking, is this differentiable and there's no picture? Well, I know the function is continuous, so I'm done with that. Vertical tangent I also know is not a problem because we learned the other day that a vertical tangent occurs when the derivative ends up being a number divided by 0. Well, I can find this derivative because that's a simple function. So f prime looks like this. That's f prime. Questions?
Because there's no fractions, it's not.
There's no fraction. So there's no way for f prime to become a number over 0.
To plug in an x at the bottom of it.
Yep. Everybody good here? Okay, the way you check for a corner is right here. So It's simple. A function is continuous if this is true. A function is differentiable if this is true. So easy to memorize because look how similar it is. So we put in a little less than 3 here. The limit of the derivative from the left is going to be 6. Do this one next because we don't really know that for sure. The limit from the right has to be this. Therefore, in the middle, it's going to be 6. There's no corner. The corner will occur if these two are different. Question? Awesome. Done with that one. Next one.
So is that E?
So the function is both continuous and differentiable. The last one of the day. Number 14. Okay, 14 says you have a function, and there exists a number c in this interval. Because c is in this interval, that tells me c is an x value. So you've got this function, looks like whatever. Draw my favorite picture. The function we're looking at from x equal pi over 2 to x equal 3 pi over 2. And somewhere in this interval, there's an x coordinate called c. We don't know where c is, but somewhere in the middle, that's where c is. But you catch up in your notes. Watching pencils. Okay, cool. So somewhere there's a C that satisfies the conclusion of the mean value theorem. On the AP test, you can abbreviate mean value theorem as MVT if you'd like. The mean value theorem is really simple. We've talked all year about secant slope and tangent slopes. The mean value theorem connects them. It states that somewhere on this interval, okay, this interval has one secant slope if you go from end to end. Just one. But it has many tangent slopes. The MVT says somewhere along here, one of the tangents will be exactly the same slope as the secant. That's it. Okay? It could be more than one, but at least one. So the MVT links secant to tangent.
Can you repeat the definition of that one more time?
So it simply says that there's one secant on this interval, and one of the tangents, at least one of the tangents, will be the same as the secant. The theorem is only valid if the function is both continuous and differentiable. So another flashcard for you. Question? This one wants us to figure out where. That's what they mean when they say, find, what's the value of c which will satisfy the mean value theorem? They're asking the question. At what point along the curve is the tangent going to match the secant? At what point along the curve is the tangent going to match the secant? Please.
Wait, are you just asking me to guess?
No, I'm sorry. I thought you raised your hand. Sorry. I thought you had a question. My bad. You just moved. Anybody else? Okay. So, anybody need me to clarify what MVT means? Secant matches tangent. Okay? Well, let's check the whole room. Raise your hand again if you remember what this is for. Always. Like, what's the purpose of this always? Like, I'm trying to get you to get to the point where I don't have to ask you the question. You just read a problem and your brain goes, oh yeah, this is what, Rachel?
Just a list of x's and y's.
This is just the list. How many do it? Point. So I know the x here, so I can find the y. Because that's the list generator. So I use the list generator to find the y here. So I go find f of pi over 2. I prefer to say 1/2 pi. So f of 1/2 pi is going to be the sine of 1/2 multiplied by, here I guess it's say pi over 2. So that's the sine of pi over 4. So I immediately think of a circle. I remember that pi over 4 is right here. I remember the sine is the up and down. At the force, everything's root 2 over 2. I'm done. You'll never have a unit circle quiz in this class. You'll never have a unit circle test. But you will just be working a problem, and suddenly you must remember the unit circle. You're done. So, please.
How did you get like the alpha of 1/2?
So tell me again what this is. Just talk to me.
It's a list of inputs and outputs.
Perfect. I know the input here is 1 pi over 2. So I use this to find the output.
Oh, okay.
Does that make sense?
Yeah.
2 point. Please.
How did you get sine 1/2 and then pi over 2 by plugging pi over 2 for x?
So this is how the list is generated, right? So x, so really this is just sine of 1/2 x. But the x I'm interested in is pi over 2. You see it? 2 points.
Are we gonna have to find 2 y's to find the secant slope?
Well
Okay.
done. Because to find the secant slope, I've got to know this point minus this
Okay,
point.
so that was just finding the y value for the bottom point?
Mhm.
Okay.
So I'd repeat it for the 3 pi over 2. So we go find f of 3 pi over 2. That's the same thing as sine of 3 pi over 4. I think of the circle. 3 pi over 4. Let's see, 1/4, 2/4, 3/4. Sine is the up and down. The fourths are always root 2 over 2. So it's the same thing. Question? Awesome. Okay, now, okay, I say this a lot, but in my opinion, you're not taking calculus to learn calculus. You're taking calculus to learn that you can think far better than you ever thought you could think. You're much better at thinking than you are at copying. You always have been, okay? You just fallen into habits of just copying. So we need the secant slope from here to here.
But the y,
Say it louder, Hadley.
the y doesn't change.
The y doesn't change. Secant slope is change in y divided by change in x. If the y doesn't change, say it out loud. What's the secant slope? 0. On that interval, the secant slope is 0. Okay, listen close. Hey, don't leave. Listen. Does anybody have a question on why the secant slope is 0? Okay, so slope means change in y divided by change in x. You okay with that? So you'll see it. How much does the y coordinate change from this end to this end? It doesn't change at all. So the change in y is 0 divided by whatever would be 0. Okay, listen, I'm going to finish this. The video's still running. It's this close to the end. If you want to stay, you can stay. If you need to go to class, go ahead and go. But I'll finish this. You can just watch the last 5 minutes on the video. Homework is 1 through 25. You can look up the answers on the website. So, good work. I'll wait for the room to clear, then I'll finish so it's not so loud. So all right. So is everybody okay that the secant slope is 0? Okay, they're asking us to figure out where is the tangent slope also 0? Because that's the mean value theorem. Somewhere the tangent slope will match the secant slope. You good? So Rachel was right. The way we find the secant slope is we find the endpoints using our list generator. Now we need a way to find the tangent slope. How do we find the tangent slope?
The derivative.
Derivative. Because the derivative is the tangent slope calculator, right? Can I erase all this?
So do you take the derivative of the...
So I take this formula, and I find the derivative of that formula, which is the cosine of pi x over 2 multiplied by the derivative of x over 2, which is 1/2. So that's the formula that can be used to calculate any slope on the curve. Just plug in an x and we'll find the slope. If we write it like this, it's maybe a little easier to see. Is everybody okay with that? Okay, now first period I said something. I said it this period as well. I said, look, the goal of this class is to get you to be better at thinking. It really is. So we found that the secant slope for that interval is equal to 0. So we want this formula for some x to be 0. Question? Okay, we can solve this algebraically, but I think it's actually better if you can think through how to solve it without doing any algebra. Like it shows that your thinking is better. Okay, the only way this can equal 0 is if, this somehow has to be 0. But over here you've got this multiplied by this. So 1/2 times something. So will the 1/2 ever do anything to make this 0? No, because they're multiplying. So somehow this has to be 0. So there is some x value. When you divide that x by 2, take the cosine of that, you end up with 0. So you got to think back to the unit circle. Cosine is the distance back and forth. So right here is the cosine equal to 0. No, that distance is not 0. So say stop when we hit the point on the circle where the cosine will be 0. Okay, right there is where the cosine is going to be 0. That's because the cosine of pi over 2 is equal to 0. So what x value do we want to pick to make that statement equal to 0? Pi. Okay. Good work.
Thank you.
Wait,
Go ahead.
Wait, what about the 1/2?
So, yeah, it's hurt your head.
Yeah.
Okay, are you comfortable that we want this to be 0?
Yes.
Which means we want this to be 0.
Yeah. And I give my value.
Hold on a second.
And James, please stand for the pledge of allegiance.
Like, if the 1/2 affects it?
You're okay. So it's like many things in this class. It's like a chain of logical connections.
Mm-hmm.
So you're comfortable that this needs to be 0.
Yeah, and that needs, the other side needs
So
to
this
equal
needs to
it.
be 0.
Yeah.
So the other side is really 2 factors being multiplied.
Mm-hmm.
So these two
Oh,
things,
so if that equals 0, then...
right, these two things have to become 0 to make that 0. One of the two. This isn't going to be 0.
Yeah.
So
Okay.
right away I know this to be true. Okay with that?
Yeah.
Awesome.
And then since it's multiplied using circle of factors.
Are you guys going to try?
Well, that's how I get to here.
Yeah.
Okay with that?
Yes.
So somehow the cosine of something divided by 2 must equal 0.
No,
Well, I just start checking.
Matt and
Right here the angle is 0.
Yeah.
So if I plug in 0, this would be the cosine of 0. But the circle helps me remember all the different cosine values. The cosine of 0 is this distance. That distance is 1. So the cosine of 0 is 1, that doesn't work. As I move along the circle, I can go to other places, but the distance still isn't 0.
Until it's at the top.
Right. What angle is that?
That's 90 degrees.
In radians, pi over 2.
Oh, yeah.
Yeah, always radians for this class. You're fine. So I figured out, hey, the cosine of pi over 2 is 0. So if the x I pick is pi, this works.
Then, okay.
Really quick.
So,
Okay.
summary real quick, Rachel, since you stayed.
Never mind.
Just got me kind of excited here.
Okay.
I'm coming right now.
So the summary is this.
Okay.
We started with this function, f of x is equal to the sine of x over 2.
Thanks so much, dude.
Okay?
Okay, bye. So we should have
We don't really know what it looks like, but it turns out it's going to look something like this. Because the point over on this end is an x-coordinate of pi over 2 and a y-coordinate of root 2 over 2. On this end, it's an x-coordinate of 3 pi over 2 and a y-coordinate of root 2 over 2. Right? So the secant slope is definitely 0.
Okay.
And we figured out that when x, right here in the middle, is equal to pi, the tangent slope is exactly 0.
That makes sense.
Good
Bye, guys.
work.
Good luck.
Thank you.
You're very welcome.